Okay, good morning, everyone. Good morning to our 24 viewers. So for today, we're going to look into your module. Okay, so this is some sort of a quick review of what was written in your module as requested by most of you, as asking for some clarifications in the teaching module which was handed to you like 2 weeks ago. All right, so we're going to go over the module, which is the first part of which is on analytic geometry. And we'll start with the basic, okay, or basic concepts in analytic geometry. So let me just share to you a copy of your module. I know you have them with you, but I just wanted to share to you on your screens so we can be sure that we're looking at the same thing on our screens. Okay, so let me share that file. Oops, looks like I'm sharing the wrong file. Wait lang. Okay, here we go. All right, so we have here the rectangular coordinate system. This is not new to you because I'm pretty sure that you were introduced to the rectangular coordinate system in your algebra and of course in your geometry back in high school or analytic geometry back in high school. But let's just have a review. Okay, so when we talk about the rectangular coordinate system, is also called as the Cartesian plane or the rectangular coordinate plane, or sometimes it's called the X and Y plane. Okay, so when we talk about the rectangular coordinate system, it consists of two perpendicular lines and one drawn horizontally and the other drawn vertically, and we call them axes. Okay, axis of course is the plural for axis. Okay, so you have your x and y axis. X axis, sometimes called axis of abscissas, and the y axis sometimes called axis of ordinates. So when we talk about axis of abscissas, it's the distance of the point from the y axis. Then we also have the vertical line, which is your y-axis. It's the distance of the point from the x-axis. So it's divided into four quadrants. We have quadrant 1, 2, 3, and 4. And I'm going to show you the rectangular coordinate system using our Geogebra Calculator. I'm sure you are familiar with this, and probably some of you, or maybe all of you, have used this already. This is very useful in analytic geometry and also in calculus. So I'm just going to show you this can be accessed online using your browser, or you can actually download this as an app from the Play Store. So they have a GeoGebra app in Play Store, so you can try to check that out and download it on your phone. Okay, you'll be amazed how easy it is to graph a given equation. Okay, using your GeoGebra calculator. Okay, graphing calculator that is. So this is how your GeoGebra calculator looks like. So this one, I access this from my browser. So this is your rectangular coordinate system. So there are four quadrants here. We have the first quadrant, this one, and then we also have the second quadrant, the third and the fourth quadrant. Okay. So all points found in um, the first quadrant have positive values, okay, for your x and y. And here, for we'll have a negative value for x and a positive for y. On the third quadrant, both negative. On the fourth quadrant, x is positive and the y coordinate is negative. Okay, so if you would like to use your GeoGebra calculator, so this is how you do it. So there are tools here. So you can move, you can create a point, you can create a slider, you can intersect lines, okay, and also draw extremum, then roots, and best fit line. Okay, if you would like to find out how scattered the given points are. Okay, and so many other functions here. Okay, like that, like there's a lot of functions, so you can actually draw a line segment here. You can also draw a circle. Okay, you can construct perpendicular lines and so on. So if I'm going to plot a point here, okay, so if I'll take this one, okay, so you have that point. Okay, and we know that point A here has the coordinate 2, 4. Okay, so it has the coordinate 2, 4. If I'm going to take another point on the second quadrant, let's say I'm going to take this point. Oops, sorry. So point is here. Let's see what point is that. So we have point B. The coordinate is negative 12, 6. So your x coordinate is negative, y coordinate is positive. Okay. And another, let's plot a point here on the third quadrant and another point this time on the fourth quadrant. Okay. So we have point A, B, C, D, each belonging to the fourth quadrant, to the four quadrants. Okay. And those points are they do have this coordinate. So for point C here on the third quadrant, we have negative 16, 6. And for point D, you have 4, negative 12. So this is point 4. Okay. So this is your rectangular coordinate system. So if you haven't used a GeoGebra calculator previously, then you may access this using your browser at geogebra.org/calculator. So it will bring you here, or you can download the app. Okay. So yeah. All right. So let's share the other document. All right. So we are back. Pag medyo malabo sa inyo, you just try to access your module, ano, para medyo makita ninyo. So, this is an example of your rectangular coordinate system. This is what we did earlier in the GeoGebra calculator. So that's your rectangular coordinate system. So we now proceed to directed and undirected line segment. Okay. So when we talk about a directed line, it's a line on which one direction is chosen as positive and the opposite direction as negative. Okay, a segment of the line consisting of any 2 points and the part between is called the directed line segment. Okay, so in this figure, figure 1.2, we have a positive direction, okay, which is indicated by the arrowhead. So we have here a line going to the positive direction. Okay. Now, if the arrow goes to the left, then that would be going to the negative direction. So here, points A and B determines the line segment. So we have a line segment here, AB, okay, denoted by these 2 points. This could be AB or BA. So the distance from A to B measured in the positive direction is positive, whereas the distance from B to A measured in the negative direction is negative. Now, guys, for directed lines, if you see a distance that is negative, the negative distance there only tells you the direction of the line segment, because you might argue that why do we have a negative distance where in fact there is no such negative a thing as negative distance, okay? But for directed lines, there is a negative distance, only that the negative sign there tells you that direction of the line, the directed line segment. Okay, so if it's negative, it means that the line segment goes to the left. If it's positive, it means that it goes to the right. Okay, that's why we call them the directed distance. Okay, so I hope that's clear to you. So for example here, if AB in our example is equal to positive 5, so we know that the direction goes to the right. However, if it's BA meaning the arrow goes to the left, so the distance or directed distance is negative 5. Okay, so therefore the distance on a directed line segment satisfy the equation AB going to the right, or line segment AB. Then we have negative BA. Okay. So another concept with respect to distance on the segment AB is that of the undirected distance between A and B. Okay? So kanina, pinag-usapan natin directed distance. Okay, so this time we have undirected distance. I'm getting a blurry screen on my YouTube. Okay, medyo blurry din ba yung screen ninyo? I don't know if medyo blurred yung screen din ninyo. Kasi sa akin, blurred yung lumalabas. That's the reason why I do not like uh, having classes in the morning, because medyo mahina yung Wi-Fi kasi maraming gumagamit. That's why I always prefer to do it late in the afternoon. Okay? Yeah, so medyo blurry. Hindi daw naman. So most likely, it has something to do with probably with our signal. Okay, yung mga medyo blurry yung kanilang mga uh, screens. But don't worry, kapag malakas na yung signal ninyo and if you're going to watch this again, hindi na siya blurred. Okay? So, yun yung maganda doon. Alright, so we proceed with undirected distance. When we talk about undirected distance, it's the length of the segment taken as positive. So the notation to indicate the positive measurement of distance A and B, or the length of the line segment AB, is AB with an absolute value, or BA, okay? Or it's the absolute value of the distance between A and B, okay? So for example, dito, AB, okay? So if you get the absolute value of 5, that will give you positive 5, okay? So for BA, you have negative absolute value of AB or negative absolute value of BA. That will give you a negative 5, okay? So relative to this concept, we have the following definition of absolute value, okay? The absolute value of a real number R, denoted by this, is the real number such that the absolute value of R is equal to R when R is positive or 0. Okay? The absolute value of R is equal to negative R when R is negative. Now, do not be confused by the negative R here. Baka sabihin nyo na, sinasabi mo kanina, sir, pag undirected distance, it's always positive, okay? Well, the definition of absolute value says that the absolute value of r is equal to negative times r, where r is negative. So, for example, if r is negative 5, the absolute value of negative 5 is equal to negative times negative 5, which is positive. Okay? So that's what it means. It doesn't mean na negative yung magiging absolute value ng r. It's just that if r is negative, you multiply it with negative, it will become positive. Because we know that the absolute value of any number, real number that is always positive. Okay? So just like in this example, positive 5, absolute value is positive 5. Absolute value of negative 5 is negative times negative 5. It will give you positive 5. And the absolute value of 0 is equal to 0. Now we move on to the theorem. If A, B, and C are 3 points of a directed line, then the directed distances by this point satisfy the equation. Okay. Directed distance AB plus directed distance AC is equal to AB plus BC is equal to AC. Okay, or AC plus CB is equal to AP. Okay, or we can also have here BA plus AC is equal to BC. This is for your directed distance. Okay. So you can actually try this, plot an arrow and name the points A, B, C, okay, and see if what we're saying here is actually true, okay? Or let me try, no, medyo mahirap kasi if you're going to toggle, from one screen to another kasi medyo limited yung function nito. But of course, if we have points A, B, C, B being somewhere between A and C, and it's a directed distance, so from A to B plus from B to C, that will be from A to C. Okay, so you can try that by drawing an arrow, like what I said, containing 3 points A, B, and C. Sorry. We have it here. So ito yon, A, B, and C. Okay, so A, directed distance A plus B, AB I mean, plus BC will give you AC. Okay. Or baliktad, CB, BA will give you CA. Okay. All right. Now we move on to the distance formula. Okay. The distance between any 2 points of the coordinate plane is the length of the line segment connecting them with, which is measured by the number of units along the line between them. So the line segment may be horizontal, vertical, or slant. If it's horizontal or vertical, it's a lot easier to, you know, uh, find for the distance, okay? Kasi it's horizontal or vertical. So mas madali lang siya. So for example, for horizontal line, okay, pag sinabi natin horizontal line, a line that is parallel to the x-axis or the x-axis itself. Okay. So if we take 2 points that will form a horizontal line, if we let, do we have that? Okay, so we have here, if we let point 1 having the coordinate x1, y, and point 2 having the coordinate x2, x sub 2y, be 2 points on the horizontal line, then the distance between P1 and, or point 1 and point 2 is just the differences of the x values, okay, or x coordinates. So we have x sub 2 minus absolute value of x sub 2 minus x sub 1, or you can also have the absolute value of x sub 1 minus x sub 2. We're going to take a look at the proof later on. I think the proof is provided in this module. Now for vertical lines, Okay, horizontal line, you just take the absolute value of the differences of the x coordinate. For a vertical line, you just take the absolute value of the differences of the y coordinate. Okay. Now, for slant line, we will make use of the distance formula. And I'm sure all of you are pretty much familiar with the distance formula. Okay. So we have d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, how did we obtain this? Okay, we will be able to derive the distance formula by drawing a right triangle, okay, that looks like this in figure 1.5, okay? Take note, we're talking about distance formula here, so we can make use of the right triangle to prove or to derive the distance formula. So let's assign values. Let's say we have a point 1 here, having the coordinates x sub 1 and y sub 1. Point 2, the coordinates is x sub 2 minus y sub 2. So if we have these 2 points, then we can draw a point, we can assign a point P3 here, having the coordinates x sub 2, okay, and y sub 1. Ito yon. So we have y sub 1 here, y sub 2, x sub 1, x sub 2. So the coordinate of P, if kukunin mo dito, will intersect at x sub 2 minus y sub 1. So same is true here. Okay. Now, if we would like to find out the distance from P1, point 1 to point 2, which is a slanting line, ito, kung gusto nating malaman kung anong distance niyan, what we can do, just like what I said, is to draw a right triangle. Okay, from point P2, we draw a vertical line. And then from point P sub 1, we draw a horizontal line. And the intersection is the point P3. Okay, and you see that we were able to form a right triangle. Okay, now when we talk about the relationship of the sides of a right triangle, we know that c squared is equal to a squared plus b squared, the Pythagorean Theorem. Okay, since C here is the hypotenuse and we would like to solve for the hypotenuse, so we can make use of the Pythagorean Theorem. C squared is equal to a squared plus b squared. So this will be your a squared and b squared. And we know that the distance from point P sub 1 to point P3, which is your A in the Pythagorean Theorem, is x sub 2 minus x sub 1. So, sa Pythagorean Theorem, sabi doon is A squared plus B squared is equal to C squared. So, if this is A, we will just square x sub 2 minus x sub 1 quantity squared, which is this. And then we have b squared in the Pythagorean theorem. This side is b squared, and the measure of b is y sub 2 minus y sub 1. So since b squared in the Pythagorean theorem, we're just going to square that. So we have here quantity y minus y sub 2 minus y sub 1 squared. So since we are looking for the hypotenuse c, we do not know what c is. And in the Pythagorean theorem, c is being squared. So p sub 1 to p sub 2 squared. Okay, p sub 1 to p sub 2 squared. Now, since we are solving for the distance from p sub 1 to p sub 2 squared, we're just going to extract the square root of both sides. Okay, hence the square root in this sa inyong distance formula. So basically, that's how we derive the distance formula. Okay, so we have an example here. Find the distance between the given points 3, 5, and 3, 1. Okay, let's try to graph that. 3, 5, and 3, 1. Gamitin natin yung ating GeoGebra. Where is it? Okay, so all right. Let's just remove the points. So what we are plotting here is 3, 5, and 3, 1. So let's find out where 3, 5, and 3, 1 is. So 3, oops. So we have here 3, 5. So that's 3 and 5. Ooh. I haven't used this app for a long time. So yeah. So that's 3, 5. Let's see if it is 3, 5. Yeah. That's 3, 5. And then the other point in the example is 3, 1. So we have here 3, 1. So you notice that if we connect A and B, it will form a line that is parallel to y-axis, or it's a vertical line. So we made mention that if it's a vertical line, okay, or a line that is parallel to the y-axis, what we're just going to do is just to get the absolute value of the differences of the y coordinates. So in our given, the y coordinates are 5 and 1. So if you take the difference of 5 and 1, 5 minus 4, so we know, therefore, that the distance from point A here to point B is just 4 units. Okay, so that's 4 units. Okay, so can you guys follow at this point? So yeah, that's a vertical line. All right, so let's try the other example. So how about if we would like to find for the distance between negative 5, 1 and 5, 4. Okay, let me just graph that, plot the points. So we have here negative 5, 1 and 5, 4. Oops. So yan. So lipat na lang natin ito. So you have here, let's connect. From B towards that point. Oops. Wait. Dali lang ah. Let's try to move this. So let's try to connect. Nawala na tuloy ako. Anyway. Just hold on a sec. At medyo... Ayan. So what we are plotting here is... I-stick itong ano ko. Wait lang. Slider. Hindi siya mag-move. Okay, so it's frozen. Hold on. Wait lang ah. Nag-freeze eh. So let's just go back to the module. So there you go. And this one is frozen too. Yun. Finally, it moved. Okay, so here we go. So for the second example, we are being asked to find for the distance between the points -5, 1, and 5, 4. Okay. So if we're going to plot this, you'll see that it's a slanting line. Okay. It's not a horizontal or a vertical line. So this time we are going to make use of our distance formula. Okay. Different. So if this is your x sub 1, okay, and this is your x sub 2 and y sub 1, y sub 2, we can just substitute them in the formula. So we'll have 5, the quantity 5 minus -5 squared plus 4 minus 1 squared, quantity squared. So you will have 10 squared plus 3 squared, square root. So you have square root of 100 plus 9. So you will have square root of 109, or that's roughly 10.44. Okay. So that's a distance from point P1 to P sub 2. Okay, so basically, ganun lang yung pwede nyong gawin. Okay, for the distance formula. Now, we proceed to the midpoint, or the division of a line segment. To find the point located some fractions of the way from this is from point P1, P sub 1 to point P sub 2, it is possible to express the coordinates of that point in terms of coordinates of point P1 and P2. So for example, if you let P1 with the coordinates x sub 1, y sub 1, and P2 with the coordinates x sub 2 and y sub 2 be given, and let Px sub y, or P having the coordinates, point P having the coordinates x, y, be the point we want to find. So if you're going to draw that, let's say ito. So if we have here P1, then we have P2. Okay. So for this figure, points 1.6, if we let R be equal to P1 to P, okay, P1 to P here, over P1 to P2, okay, where R is the ratio of the distance P1P to distance P1P2, when point P is located 1/4 of the way from point P1 to point P sub 2. And our R here is 1/4. Or we say that P is located 2/3 of the way, where R is equal to 2/3, and so on. So by projecting P1, P2, and P onto the x-axis to the given points, P1, P sub 1 sub x, and P sub 2 sub x, and P sub x respectively, then we will have now here this proportion. Okay, R is equal to P sub 1 to P sub 2 over P sub 1, P sub 2 is equal to the ratio of P sub 1 sub x, P sub x, so, and P sub 1 sub x, and P sub 2 sub x. Or in other words, this is just equal to x minus x sub 1 over x sub 2 minus x sub 1. So where do we get our x sub 1 and x sub 2's here? Okay, it's of course given in the point. Okay, so if you would like to find out for the ratio, okay, so solving for x, we get x is equal to x sub 1 plus the ratio r. Okay, ito pwede nating, if you would like to solve for x here, x is equal to x sub 1 plus the ratio r times the quantity x sub 2 minus x sub 1. Okay. If we're going to project P1 or P sub 1, P sub 2, and P onto the y-axis, so we have, okay, y now is equal to y sub 1 plus the ratio r times the quantity y sub 2 minus y sub 1. So these two formulas are called the point of division formulas. And we can make use of, it's stated in the theorem that if point A is equal to the point x sub 1, y sub 1, and B, x sub 2, y sub 2, and P is a point such that R is equal to the distance from A to P over A, the distance from A to B, then the coordinates of P, given a point P, halimbawa, pinapahanap yung coordinate ng P, is given by this, like the one I just showed you on how it was derived. Okay, so for example, ipapahanap sa inyo any point between P sub 1 and P sub 2, like let's say P, okay, then you can find for the coordinate of this point, a point anywhere in between P sub 1 and P sub 2 using this theorem. Okay, so the x coordinate is given by this and the y coordinate is given by this. So we call that the point of division formula. Okay, so we have here another figure. So we have point A, given point A with the coordinate x sub 1, y sub 1, and point B with the coordinate x sub 2, y sub 2, and say you are asked to find for the coordinate P, xy, then you just make use of this formula here, where r here is x sub 2 minus x sub 1. Okay, so let's try to apply that in an example. So here, find the point 1/3 of the way from A, point A with the coordinates 2, 5, and point B with the coordinates 8, -1. So if you're going to draw that in the Cartesian plane, so you will have this. So we have a point P. Okay, we do not know where point P, but what we only know is that it lies between A and P. Okay, so first we have R, but it says it's 1/3 of the way from point A to B. So we know that R here is equal to 1/3, okay? Because it says 1/3 of the way. Now, so we can solve for the x coordinate. So x is equal to x sub 1 plus R times the quantity x sub 2 minus x sub 1, okay? So let's say if you assign A as your x sub 1, y sub 1, and B, x sub 2, y sub 2, we know that x sub 1 here is equal to 2. This is x sub 1. Plus r, which is 1/3 given, times the quantity r x sub 2, r x sub 2 here is 8, minus x sub 1, which is 2. So 8 minus 2. So simplifying this, you'll have the x coordinate, which is equal to 4. Now we need to find for the y coordinates. So we'll do the same. We use the formula in the given theorem. So y is equal to y sub 1 plus r times the quantity y sub 2 minus y sub 1. So from the given, we know that ry here, sorry, this should be y. This is y, not x. So y here, y sub 1 here is 5. Ito yon, di ba? X sub 1, y sub 1. So y sub 1 is 5 plus r given, which is 1/3, times the quantity y minus 2. Y minus 2 here is negative 1 minus y sub 1, which is 5. So simplifying this, we have y is equal to 3. So therefore, the desired point is at 4, 3. Okay? So nasa 4, 3 siya. Of course, this is a rough illustration. Ano? In analytic geometry, it's very helpful if you're going to visualize what is being described in the problem by drawing them, by plotting them in the Cartesian plane, so that you will have a better understanding of what the problem is all about. Okay. So yeah. So we have other examples here. So basically, you will do the same process because same is given. Here we no, this time we are given a point, one end point, and the point at the middle, and you are going to find for the other end point. Find P. So we just make use of the two formulas, okay, the two equations from the theorem to be able to find for the endpoint. So when we talk about endpoint here, B, if you're talking about endpoint B, what you're solving for here is x sub 2 and y sub 2. Okay? So we have here x1, x sub 1, y sub 1, x sub 2, y sub 2, and we have our r, which is 3 over 5. So r here is the ratio. Okay? So we have x is equal to x sub 1 plus r times the quantity x sub 2 minus x sub 1. So x is given, which is 8. Dito yan. Yung from p, this is xy. Ano? Inulit ko. X sub 1, y sub 1, this is x, y. Right? So we have x is 8, x sub 1 is 2, r is 3/5, x sub 2 is the unknown, and x sub 1 is 2. So if you manipulate this, you'd be able to find for the value of x sub 2, which is 12. Okay. And then the same is true here. You do the same process here. You'll find that out therefore that y sub 2 is equal to 1. Okay, thus B is 12, 1. Okay, so yeah. So ito wala na tong 3 dito. Wala na rin yan. So you divide this by 1. So yeah. Oops. So there you go. So y sub 2 is 1. Right? So I'm going to leave the other examples to you. That's for the division of line. Now we also have the midpoint formula. The midpoint formula is derived from the same idea with how we derive with the theorem that we just talked about earlier. So if you want to derive this, so I'm going to leave that to you. But of course, when we talk about the midpoint formula, okay, when we talk about midpoint formula, it's a point between points A and P that will divide the line segment into two equal parts. That's why it's called midpoint. Now, to solve for the midpoint, for example, P, with the coordinates x and y, we just solve x is equal to the 1/2 the sum of the x coordinates, x sub 1 and x sub 2. And for the y coordinate, we just have to take half of y sub 1 and plus y sub 2. So that's for the midpoint formula. Okay. Okay. So yeah, we don't need to discuss that because you can solve for P by using the previous formula. No? So example here, find the midpoint of the segment AB where A 1 and B is 2. So we have 1/2. Find the midpoint of the line segment AB 1, 5, and negative 3, 1. Let's try to see kung ano itsura ng mga points na yan. Okay, so we have points. Wait. Medyo mahirap magturo ng math online, okay, unless you have the necessary software na pwedeng gamitin. Pero with what I am using right now, it's a bit challenging. Okay, so let's see the problem. We're going to find for the midpoint of the point A 1, 5. So let's see where that is. So this is point A5. 1, 5, I mean. And we have negative 3, negative 1. So that's it. Then let's see if we can connect it. Okay, so we have here now, we were able to find for C, which is the midpoint of this segment, A, 1, 5, and B, negative 3, negative 1. So this is the midpoint which is given by negative 1, 3. Medyo may mali dun sa module ninyo because in the module, sinubtract niya. It should be add. You add the x coordinates, x sub 1 and x sub 2 over 2, half of that, then half of the sum of y sub 1 and y sub 2 to find for the midpoint, which is negative 1, 3. Okay, so let me share the module again. Okay, no, I think it's already 12 o'clock. So it's lunch break. So we're going to schedule another one tomorrow. So we can talk about slopes of a line. Okay, do you guys have questions? What are there things that you would like to ask part of the module that you have? Maybe you would like to clarify at this point. Just like what I said, it's very helpful for the first part of our course if you make use of your GeoGebra calculator or you download the software from your Play Store. Madali lang siya. Sometimes, madali din mag-solve kasi meron formula na pwede nating i-input dito sa software na ito. App. Okay? So, pwede kayong mag-solve even for calculus. Pwede nyo gamitin yan. Okay. Do you guys have questions? Or are you still there? Because it's already 12, so I think I have to end this live broadcast and we're going to schedule another one. And hopefully I can make use of a whiteboard next time. And I will use a second camera. So parang nasa classroom pa rin tayo. But I have to set that up first. I just need a whiteboard and a marker. And then I'm going to make use of another gadget for the second camera. So we can solve like we are solving inside the classroom because I'm pretty sure that's the one that you're looking for. Kaya nagre-request kayo ng live discussion. Okay? So I'm going to try to set that up for you next meeting. So yeah, I think that's it for today. I'm going to see you again tomorrow, right? Okay, so have a great day, everyone.